I'm going to start with free body diagrams as always. So MA, our forces that are acting here, I'm going to call this tension. We have MAG, got a normal force for A, and then we have this tension. On our MB, we've got a force pulling in this direction. We have our tension, which is equal to this one over here, pulling in the opposite direction. We're going to have MBG, and we're going to have a normal force. Next step is to find the acceleration of the cards. Let's go through free body diagram, the equations, and do it the long way first. But you can probably already figure out the answer doing it the short way, but it's a way to check that you're right. On this one, in the x direction, that's the only direction we need to worry about. I'm going to make this be positive. So we're going to have tension is equal to MAA. On this one, we're going to have force minus tension is equal to MBA. We're going to take our value of tension. We're going to plug it in for tension over here. That's going to give us the force minus MAA is equal to MBA. Force equals MAA plus MBA. Factor out an A. And A is equal to force minus MA plus MB. And again, if we were going to figure out this using the short way, we'd have this whole system right here. The net force acting on that system is just that force. Which is just what we got. So then part C, we're figuring out the tension. We have to do the free body diagrams and the equations in order to get an equation for tension, but to get acceleration, we can use the short version. So our tension is equal to MA times A. So this is MA times force over MA plus MB. A lot of people really don't like having problems where there's no numbers. But in this case, in the case of forces, it's actually a lot easier because now we don't have to plug anything in. We're already done. This is the end of what we need to do. Everything's in terms of force, MA, and MB.